Introduction to VPC network peering. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today we're exploring VPC network peering in Google Cloud Platform, one of the most fundamental ways to connect VPC networks. When people ask about cloud peering in GCP, they're typically referring to VPC network peering, which allows you to connect two VPC networks so that virtual machines in different VPCs can communicate using internal IP addresses. Think of VPC peering as building a private bridge between two separate networks. Once established, resources in both VPCs can communicate as if they were on the same network, but with important distinctions. The VPCs remain administratively separate, maintain their own firewall rules, and can even belong to different projects or organizations. This technology is crucial for several scenarios: connecting development and production environments, enabling shared services architectures, facilitating cross-organization collaboration, and building hub and spoke network topologies. Let me explain the mechanics of how VPC peering works. When you establish a peering connection between two VPCs, you're essentially programming Google's software-defined network to route traffic between them using internal IP addresses. This happens at Google's network layer, not through any virtual appliances or gateways that you manage. The beauty of VPC peering is its simplicity and performance. Traffic between peered VPCs stays on Google's private network. It never traverses the public internet. This means you get the same low latency and high bandwidth as communication within a single VPC. Google handles all the routing automatically once peering is established. Each VPC maintains its own identity and configuration. Firewall rules are not shared. You must configure rules in each VPC to allow the desired traffic. Similarly, routes are exchanged automatically for subnet routes, but custom static routes are not shared by default unless you specifically export and import them. The peering relationship is always between exactly two VPCs. If you have VPC A peered with VPCB, and VPCB peered with VPCC, VPCA cannot communicate with VPCC through VPCB. This is called the non-transitive property of VPC peering, and it's a critical concept to understand for network design. Key characteristics and benefits. VPC peering has several key characteristics that make it powerful yet require careful planning. First, it works across projects and even across organizations. This means you can peer a VPC in your development project with one in your production project, or peer your company's VPC with a partner's VPC in their organization. The connection is established using internal IP addresses only. This is both a benefit and a constraint. It's a benefit because traffic stays private and secure, but a constraint because you must ensure IP ranges don't overlap between the peered VPCs. If two VPCs have overlapping subnets, peering will fail or cause routing issues. From a cost perspective, VPC peering is very attractive. There are no charges for the peering connection itself. You only pay for the egress traffic between VPCs if they're in different regions. Traffic within the same region is free, making peering an economical choice for same region connectivity. Performance-wise, peered networks communicate at the same speed as instances within a single VPC. There's no bandwidth limit imposed by the peering connection itself. You're only limited by the virtual machine instance bandwidth limits. This makes peering suitable for high-throughput applications like data replication or distributed computing. Limitations and constraints. While VPC peering is powerful, it has important limitations you must understand. The most significant is the non-transitive nature I mentioned earlier. You cannot create a multi-hop network through peering. Each VPC pair needs its own direct peering connection, which can lead to complex mesh topologies in large deployments. IP address overlap is another critical constraint. Before establishing peering, you must ensure that the subnet ranges in both VPCs don't overlap. This requires careful IP address planning, especially in large organizations. Once peering is established, you cannot create new subnets that would overlap with the peered VPC. There's a limit on the number of peering connections per VPC, currently 25 by default, though this can be increased. However, managing many peering connections becomes complex. Each connection must be accepted by both sides, and you need to track which VPCs are peered with which others. Some features don't work across peering connections. For example, you cannot use private service connect endpoints across peered VPCs. Internal load balancers can be accessed across peering, but there are specific requirements. Shared VPC and VPC peering have some incompatibilities you need to understand when designing your network architecture. Setting up VPC peering. Let's walk through the process of setting up VPC peering. It's a two-step process requiring action from both VPC administrators. First, one side creates a peering connection request, and then the other side must accept it. Both sides must have the necessary IAM permissions, specifically, the Compute Network Admin role or equivalent custom permissions. To create a peering request, you need several pieces of information: your VPC network name, a name for the peering connection, and the project ID and VPC name of the network you want to peer with. The command would be G Cloud Compute Networks Peerings create my peering network equals VPC1, peer project equals other project, and peer network equals VPC2. The administrator of the other VPC then sees this as a pending request. They must create a corresponding peering connection back to your VPC to complete the handshake. Once both sides have created their peering connections, the status changes from pending to active, and traffic can flow. Route exchange happens automatically for subnet routes, but you can also configure custom route export and import. This is useful when you have static routes to on-premises networks that you want to share across the peering connection. You configure this using the Export Custom Routes and Import Custom Routes flags. Let's explore common use cases and patterns for VPC peering. One of the most popular is the shared services pattern. You create a central VPC containing shared resources like databases, monitoring systems, or security appliances. Other VPCs peer with this central VPC to access these services. This avoids duplicating resources and centralizes management. Another common pattern is environment separation. You might have separate VPCs for development, staging, and production, but need them to communicate for specific purposes like data synchronization or deployment pipelines. Peering allows this while maintaining network isolation and separate security policies. Cross-organization collaboration is increasingly important. Companies working together might need their applications to communicate securely. VPC peering enables this without exposing services to the internet or setting up complex VPN connections. Each organization maintains control of their VPC while allowing specific communication. For disaster recovery and high availability, you might peer VPCs in different regions. Your primary application in US Central 1 can peer with a DR environment in Europe West 1. During failover, applications can continue communicating using the same internal IP addresses, simplifying DR procedures. VPC peering versus other connectivity options. It is important to understand when to use VPC peering versus other connectivity options in GCP compared to shared VPC. Peering provides more organizational flexibility, as VPCs can be in different projects or even different organizations. However, shared VPC offers centralized control and simpler management for resources within a single organization. VPN connections are another alternative. While VPN can connect any networks, including on-premises, it requires managing VPN gateways and has bandwidth limitations of 3 gigabits per second per tunnel. VPC peering has no such bandwidth constraints and does not require any gateway management. However, VPN is necessary for connecting to non-GCP networks. Private Service Connect is a newer option that provides more granular control. Unlike VPC peering, which connects entire networks, Private Service Connect exposes specific services. It is useful when you want to share a particular service without opening up your entire network. For connecting to on-premises networks, you would use Cloud Interconnect or Cloud VPN, not VPC peering. However, you might peer your VPC with another VPC that has the on-premises connection, creating a hub-and-spoke topology. This is a common pattern for centralizing on-premises connectivity. Security is a critical aspect of VPC peering. While the connection itself is secure, with traffic never leaving Google's network, you must carefully configure firewall rules to control access. Remember that peering connects networks, not just specific resources. Without proper firewall rules, all resources in both VPCs could potentially communicate. Each VPC maintains its own firewall rules. A common mistake is assuming that establishing peering automatically allows traffic. You must create firewall rules in both VPCs to allow the desired communication. Use the principle of least privilege, only allowing the specific ports and protocols needed between specific resources. For compliance scenarios, VPC peering can help maintain data residency requirements. Since traffic stays on Google's private network within a region, you can ensure data doesn't traverse public networks or leave specific geographic boundaries. This is important for regulations like GDPR or industry-specific requirements. Audit logging is essential for compliance. Enable VPC flow logs and firewall rules logging to track communication between peered VPCs. Cloud audit logs also capture peering connection creation and deletion. Regularly review these logs and the list of active peering connections to ensure they align with your security policies. Troubleshooting and best practices. When troubleshooting VPC peering issues, start with the basics. First, verify that the peering connection is active on both sides. A common issue is forgetting to accept the peering request. Use the G-Cloud Compute Network's peerings list command to check the status. If it's stuck in pending, it means the other side hasn't completed their configuration. Next, check for IP address overlaps. Use the G-Cloud Compute Network's subnets list command for both VPCs and ensure no ranges overlap. Even partial overlaps will cause routing problems. If you discover overlaps after peering, you'll need to delete the peering connection, fix the IP ranges, and re-establish the peering. Firewall rules are the most common source of connectivity issues. Use VPC flow logs to see if traffic is being dropped. Remember to check rules in both VPCs. A helpful troubleshooting technique is to temporarily create a very permissive rule to test connectivity, and then tighten it once communication is verified. Best practices include documenting all peering relationships in a central location, using descriptive names for peering connections, implementing a consistent IP addressing scheme across your organization, regularly auditing peering connections to remove unused ones, and automating peering setup using infrastructure as code tools like Terraform to ensure consistency. Exam tips and key takeaways. For certification exams, remember these key points about VPC peering. First, it is non-transitive, and this is frequently tested. If A peers with B, and B peers with C, A cannot reach C through B. Each pair needs direct peering. This is different from traditional network routing and catches many people off guard. Second, IP ranges cannot overlap. Exam questions often present scenarios with overlapping subnets and ask why peering fails. Always check for overlaps first. Remember that you cannot create overlapping subnets even after peering is established. Third, understand the administrative boundaries. Peering works across projects and organizations, but both administrators must take action. Neither side can force peering. It requires mutual agreement through the two-step setup process. Common exam scenarios include choosing between VPC peering and shared VPC, where peering is for cross-organization needs, and a shared VPC is for a single organization. You might also need to calculate the number of peering connections needed for a full mesh topology, using the formula n times n-1, divided by 2 for NVPCs. Also, understand that firewall rules don't automatically allow traffic after peering, and know that custom routes are not shared by default without an export/import configuration. Thank you for your attendance. Please consider subscribing to the channel.